Hey everyone, and welcome to our Thursday Text Bar. My name is Ivy. I'm the account manager here at Meanwhile. And joining with us today, we have Karim, our expert. He is our field application engineer.
Hello, Ivy. Hello, everyone.
Hey Karim. So today we are going to tackle a question that's being asked all the time. Like, what is the difference between product warranty, product lifecycle, and the MTBF? Yeah, this is actually a crucial question to any engineer, product manager, as well as buyers, essentially everyone in this industry. So understand these terms will help us better manage our customers' expectations, make better design decisions, and hopefully we can give our customer better confidence about Mimo product as well. So Kareem, do you want to start a kick off by diving into the first term, the product warranty?
Yeah, of course. So for the product warranty is the commitment from Manual to the customer that our product is gonna meet the spec what we mentioned on the data sheet, and also gonna be high quality and high performance power supply. And from the picture you guys seeing here, we offer like a different variety of the warranty years. 2 years warranty for the LPV series, 3 years warranty for the LRS series. For the BHP series, for example, we offer 5 years, and the highest warranty year we offer for the HLG series 7 years. So during this years, if the product has any manufacturing or has the quality issue, so the customer can basically call the distributor and say the unit has a problem, and the distributor he can issue an RMA, and we're gonna take care of the RMA. So maybe we're gonna replace the unit or fix the unit and send it back to the customer. Yeah.
Yeah. So thanks for the introduction. It really highlights a warranty isn't just a number, it's our promise to our product and services. And Karim, you just mentioned if a product and fails within the warranty, and meanwhile will be fixed with no cost. For example, if I drop the power supply into the water and it fails, is that
No.
covered by warranty?
No, this is called misuse. So there is exception for the warranty. There is a misuse for the customer if they misuse the unit. So they have to back to the spec. Like for example, like the example you give, the customer using the unit for outdoor application, and the unit is designed for the indoor application. This is avoid the warranty. For example, if the unit is up to 264 volts, and the customer applying 277 or 300 volt, this is also it's called as misuse. So it's always referring to the data sheet. Whatever the data sheet is saying, this the customer has to follow what we're saying and mention on the spec.
Yeah, understood. So there are two crucial points here, and it's our actually disclaimer here. So the first one, we need to use the product within the spec. Any misuse of the product will lead to the void of the warranty. And secondly, do not try to do the modification or repairment on your own. If you have such a request, please contact Mingwa for help. We don't want to void the warranty because of modification or repairment.
Yeah, adding on the IV, this is one of our service. Also, we provide a failure analysis report. So if the customer needs why the unit is failed, why this has happened, so they can backfeed to us and say why this unit happened. So we can provide the failure analysis report to the customer to basically know what happened to the power supply.
Yeah, perfect. Thank you, Karim. And I actually have a question. For example, the enclosed type here, we have 5-year warranty. Like, how would we determine if this part is qualified, like for 5-year warranty?
Yeah, so to answer your question, there is 2 stages. First stage is the design stage, and second is the verification. After we design the R&D, design the unit, they have to verification. So let's get started with the design first. For the design, as most of you guys know, this is the most critical component for the power supply to determine the lifetime of the power supply or the warranty is the electrolytic capacitors. This is the most critical component. So this component basically has a liquid inside, chemical liquid inside, and this is over the time, this liquid is gonna be dry. So and the function of this of the capacitor is just to filter the output voltage. So with the filtering, with the lifetime, this capacitor, it's reducing the lifetime. And from the blue curve here, if you take the lifetime of the capacitor versus the ambient temperature, when we increase the ambient temperature, the lifetime of the capacitor, it's keeping down. So this is one of the factors that is affecting the lifetime of the capacitor, which is affected by the lifetime of the power supply. Let's take an example here. If we open the test report of the BHP unit, we're going to find out and search for the capacitor lifetime. We're going to find out the factory did 4 tests. All of them basically the testing on the 230, and the output power is various. It's full load or half load or 75% load. But what you can see on the right side here, it's the ambient temperature. We tested, like for example, the first test we tested at ambient temperature 25 Celsius. So if you see the result, it's the lifetime, it's about 1.5 million hours, the lifetime of the capacitor. But for the second test, if we tested based on the 50 Celsius, which is double the ambient temperature, the lifetime it's reduced by half. It's almost 50% reduced. So this is an indication. The most critical factor for the capacitor and the power supply is the ambient temperature. When we goes high, the lifetime also goes down. And another example here for the LED drivers. LED driver, it's the same concept. Has we here tested for three different tests, and each one of them it's full load 75% and 50. And here that we specify here with the TC. TC stand for case temperature instead of the ambient temperature. So this is the difference between the drivers and the ambient temperature. But what you can see here also, you have the full load and the 75% load and 50% load. When you see the result on the right side, you're gonna see when you reduce the load, it's also the lifetime of the capacitor keep increasing. So here there is what we can see from these 2 tests. There is 2 main factors. The first one is the ambient temperature of the capacitor, and second one is the load percentage of the capacitor. So this is the main 2 factors for the power supply and also for the capacitor.
I see. So for the HLG series, like why we are using the case temperature instead of the ambient temperature?
Yeah, so here, mainly for the LED driver, when the customer installed the LED driver, as you can see in the picture, the space is very tiny. So this is usually how they install the LED drivers. So with the limited space, the driver putting on the limited space, that is mean the ambient temperature and the case temperature of the driver, they are same. That's why we specify with the case temperature instead of the ambient temperature. But basically they are same.
Yeah, gotcha.
Yeah. And here, after we design and choose the proper capacitors and make sure this capacitor is gonna fit the application, it's gonna fit the ambient temperature, what we specify on the spec, we're gonna go for the verification. So we need to verification the units. So here an example for the BHP unit. The BHP unit, as we mentioned, it comes with 5 years warranty. So if we go to test report again and search for the reliability test, ongoing reliability test, we're gonna find out that we test the unit based on the input voltage 230, full load, and the ambient temperature 50 C. And we have something called here the demonstrative mean time between failure, which is 50 kH.
Yeah.
What does mean? That's mean if your power supply can work for 50,000 hours without any failing, that's you can guarantee your power supply it can be certified for 5 years warranty. So if we take a look on the right side, we have that small table here. This small table is not specified for the just specifying for all the product or the manufacturer, the power supply manufacturer. So if you want to certify your unit for 2 years, you have to 20K hours. You have to meet 20K hours. 5 years, 50K hours. 7 years, 62K hours. So based on those, this is what we mentioned on the design. So here for the equation, also this equation is general equation. It's not related to manual. This is a general equation. So we know now the first parameter, the MTBF, it need to be 50K to able to meet 5 years warranty. And then the other part of the equation, number 2, which is this is a constant number, And the total time, the total test time. Total test time, it's consists of sample quantity plus the burn-in days. This is the two factor that we need to know from the equation, and multiply by 24 hours to convert the days of burn-in system, like to burn in the unit, to 24 to change it from days to hours, because this equation in hours. The second term here, we have the temperature acceleration factor. The temperature acceleration factor, this is, you can get it from this equation, has the tables. And from the table, you're gonna find out at 50 C Celsius, the ambient of 50 C Celsius, you're gonna see this factor, it's fixed number 6.09. And the confidence level factor. Confidence level factor, this is a number, it's starting from 5% up to 65%. When you increase the number, you increase in the confidence level. But here we choose 10% to be more strict, to make it at the worst case. Then if you apply this equation, we're gonna have two parameters unknowing. The first one, the burn-in days, and the sample. So we're gonna consider the samples here like a 30 unit. So the factory can test 30 units. Then if we apply this equation, we're gonna get the burn-in days we needed to verify this test. It's 26.2 days for 30 units. So if we test just one power supply, that's mean we need to test the unit for more than 5 years, which is, it's not make sense to have this test that long. So instead, we increasing the number of units. So what does mean? What the conclusion from this page? It just, the R&D team gonna test the unit for 30 days up to 24 hours. And if any unit of the 30 units fail, that's mean we fail, and we cannot guarantee that to give the 5 years warranty. So the R&D team gonna go back and try to figure out the problem, then they fix and then test it again until they gonna meet the specification. So this is the summary of this page.
Oh, wow. And I noticed that there is a 50 degrees C temperature acceleration factor when we are using like 50 degree.
Because for the BHP unit to able to get the full power, the maximum ambient temperature you can get it up to, it's 50 C. So if you can go to 70%, but in this case, you have to lower the full load percentage.
Okay, got you. And basically that is being said, if we want to qualify the PHP 3500 for a 5-year warranty. And we need to have 30 of these units burn in for 26 days without any failure.
Right.
Oh, wow, that's impressive. And you also mentioned that our warranty is ranging from 2 to 7 years. Is there any reason like why we designed the different warranty periods for different products?
Yeah, this is based on the market and the product manager. When they launch a product, they're gonna see the market, how the market and the equivalent product for this on the market, how many years available in the market. So the product manager is gonna design the unit based on the availability on the market and what the strategy of the market. So it's not make sense to make all the units going to 7 years, because when you increase the number of warranty, that's increases the design. And increasing the design is cost effective. So it's gonna be like a relation between cost and the designing. So it depends on the market.
Yeah, I see. So for certain industry and applications, maybe reliability is top priority, and some other markets probably they can be cost sensitive. So when we design a part, we need to consider all the perspectives, and then we have to ensure our products can meet a wide range of industries and applications.
Correct.
Well, yeah. I also have a question. For example, if I have a product on hand, probably I purchased a while ago, like how would I verify if this is still under warranty?
Yeah, so if you go to the manual website and click on service, then on the left side, you're gonna find out the quality control inspection report. So try to click on this one. Then this page is gonna pop up, and on the unit itself, it has a serial number. So insert the serial number, then put the verification code, then click on search. On the bottom, they're gonna find out the PDF. So once you click on the PDF and open it on the first page, you're gonna see like the dating. This date is the manufacturer date of the units. So let's take the example here for this page. It's the model here on the top. It's showing the RBS-120. So this model, it comes with 3 years warranty. And here the manufacturer date, it's 2021 April. So that's mean you're gonna add three more years on top of that 2021. That's mean the warranty is gonna be end on the April 2024, which is this unit already expired.
Okay, got it. So technically, the warranty, for example, this one, the warranty covers until April 23rd, 2024. So yeah, we are trying to not to like make a cut-off line, just like a Cinderella in the midnight, something like that. We're trying to give some buffer period or grace period to our distributors. Is roughly like 3 to 6 months period, considering different situation. For example, there are transit time or probably the part stays in your warehouse for a couple of months, something like this. We try to add some flexibility like that. Yeah. And Karim, you already introduced the warranty. How about the next term, the MTBF?
Yeah, for the MTBF, it's a stand for mean time between failure. That's mean how long the production time for how long the power supply is gonna be last before it fail, like an expectation number for how long of the power supply is gonna be working. It's different from the warranty. Warranty is just for 2 to 7 years, but this is a huge number that it guarantee the unit that it's gonna work for, like the warranty it's 2 years, for example. That's not mean after the 2 years the customer gonna scrap the unit and get another unit. No, that's mean the customer has to refer to this number. So actually there is two way to and there is two standards to measure the MTBF. The first one, the SR-332, which is this more real, this is real data base, and this is mainly using for the commercial and telecommunication industry, and this is giving a realistic number. But this one, it's testing the component based on the normal operation condition. The second one, the MIL-217, this is more realistic number. This is what its manual consider, and this is most of the data sheet you're gonna see this number. This is focused on the aerospace and the military application, and this is also it's using the component and test the component based on the harsh assumption. So here an example for the IRM-60. This is a real example for how we calculated the MTBF. So on the left side here, you're gonna be the part type, and this is all the critical component inside the power supply. And on the right side, you have the quantity of those critical components, and you have like the something called the error of each component, or the like at which time this is gonna get the error code for the component. So here the test it's happening on the 50C. At 50C, you're gonna get the error or the failure rate of the component. And we using here something it's called the software isograph software. So we're gonna insert those error codes to the software, then it's gonna calculate for us. After we inserting the failure rates, it can calculate for us the MTBF, which is here it's showing 386K hours. So when the unit is 38 is 386 hours, that means it's almost the unit is gonna be last in 35 years. So when also the unit stretch to this number, that's not mean the unit it's already failed and that the customer also need to scrap it. No, this is means the reliability test. The reliability of the unit it gonna drop from 100. It gonna drop to 36.8%.
Okay. Got you. So basically, the MTBF is a statistic tool to understand the reliability of the lifespan of the mineral power supply. Just like Karim said, we always receive questions such like, hey, Ivy, I have this product on hand. It only has 3-year warranty. Do you have anything that it have longer lifespan? So just like Karim said, 3-year warranty doesn't mean it will fail after 3 years. You should always refer to the MTBF for the reliability and lifespan of these products. And also, Karim, can you also give us an example of the typical MTBF hours of mineral products?
Yeah, so here an example for the IRM-90. This is a real example. So if you open the test report of the IRM-90, you're gonna see the MTBF. It's calculated here based on the 300K hours, which is about 32 years. So, but here it's testing based on the 25 Celsius. But in the real application, sometimes the customer want the ambient temperature is gonna increase. So the blue graph here showing how the mean time between filler is gonna reduce over the when you increase the ambient temperature. So it's the number is gonna goes from 310 to 281.5 K hours when the ambient temperature decreased to 50 Celsius and so on. So when you increase the ambient temperature, the curve the number of hours again goes down, because as we mentioned in the capacitors, there is two factors on the capacitor. The ambient temperature, that's why you're seeing this curve going down when we increase the ambient temperature.
Yeah, so even with like 50-degree ambient temperature is also like 30 years or something lifespan. So hopefully this can give our customer more confidence about Meanwhile products.
Yeah.
Yeah, thank you for the introduction. And let's jump into the last term, the product life cycle.
Yeah, so for the product life cycle, we have like this is general graph. So it consists of the 4 stages here. The first stage, the R&D team, he gonna like wanna develop a product. Then after develop the product and make all the certification, test the unit, make sure the unit is meeting the specification and what it's required in the market. Then they gonna launch it. So when they launch, this is the growth. So the marketing team, they gonna promote to the unit and starting to know on the market. Then it gonna be the demand. They gonna be start on the unit. Then the third stage is the maturity, which means the unit already has the high demands, it's already popular, and all the people know it. Then after a while, the unit like during the maybe some of the component has the already end of life, or maybe the degradation, or there is a new technology happen, that so we're gonna have a decision that to decline and stop producing, and the unit is gonna go for the end of life. And this period of life for the 4 stages, it's taking for Meanwhile side, it's taking about from 10 to 15 years to last them.
Yeah, so basically the product life cycle describe the 4 stages. A product go from like initial introduction to finally end of life. And on top of what Karim said, when at Meanwhile, when we officially want to end of life a part, we always have a replacement. We will not phase out any product without any like alternatives.
Correct.
Yeah, and also Karim, can you give us several examples, maybe using Meanwhile product to help us better understand the stages?
Yeah, here for the LRS, for example, we launched it at 2015, and now it's more people know the LRS series, so it's in the maturity stage. For the NTN, we just launched it last year, so it's on the growth. We launched the unit, and the unit is getting growth. NES, that's 350. This is already we launched it in 2015, and this is already past the 15 years period. So this unit is end of life. For the XLG, we launched it at 2021. So now it's on the growth stage.
Okay, gotcha. So why the product life cycle so important?
This is for the strategy for the engineering. They gonna know this is if they have like their end product, they gonna introduce it to the market. They wanna have the strategy how long this power supply they can use it. So they gonna have like better understanding how long they gonna use the unit, and how much they wanna keep this unit, or maybe order the unit and give it in their warehouse. So it's kind of engineering strategy.
Oh yeah. Yeah, for example, if you want to design in a new part, you definitely want to avoid the part that soon be end of life.
Right.
Yeah, and I also get some questions such like, hey, Ivy, when this part gonna be end of life? Or how would I know if this part gonna be end of life? So before the part go to end of life stage, it will first go to the discontinued stage. If you go to Meanwhile website, it should be under products. If you see on the left-hand side, there are discontinued product tab as well as the end of life tab. I will just use the discontinued as an example. So if you click on the tab, you will see the list here. So on the left-hand side, you can see the old existing model, and the right-hand side, we always have the replacement models. And in the middle, you have the lead time. It has NRND and 60-day, 90-day, and last buy order. So what does that mean? I will go from the NRND. That may not recommend for a new design. When the product go to this stage, it means two things. First, if you have a new project, try to design in the replacement part instead of the NR&D part. And if you have any existing project using this part, you may want to start transition to the replacement part as soon as possible. And secondly, it could be end of life anytime after 6 to 18 months. So, and meanwhile, we always recommend you to do the transition at your earliest. And also, if we look at the 60-day, 90-day last buy order, that means you can still like purchase this part, but lead time is gonna be longer. Instead of the initial, right now the standard lead time is 30-day production, you will have 60-day, 90-day, and for the last order, it means this is the last chance you can buy this part. It will not appear on your next price list. So for example, right now we are on July price list. So the last chance you can buy this part is till December 31st, 2025. There will be MOQ requirement in multiple of 100 pieces, and we intentionally increase the price every 6 months, and we'll update the list every 6 months as well. Basically, we intentionally do this to push the transition to the replacement part. After the last order buy, it officially go to end of life, means no longer for purchase or sold. If you still need those parts, please contact meanwhile to see if we have remaining balance.
Yeah.
Mm-hmm.
So here for summarize what we said today. So we have the product warranty, product lifecycle, and MTBF. So for the product warranty, this is a commitment from the manual to the customer that we're gonna fix the unit if anything happened during the warranty time. And this is starting from 2 years up to 7 years. For the product lifecycle, this is usually our manual product. It takes from 10 years to 15 years. During this time, the engineering have a strategy to know if they're gonna use the unit or not. And for the MTBF, this is how long the power. This is prediction time for how long the power supply is gonna last before it fails. And like for example here, it's the numbers of MTBF. It's 100K hours, 200K hours, 300K hours. So when the power supply to reach to those hours, that not mean the power supply is gonna be scrapped, but the reliability of the power supply dropped from 100% to 36.8%.
Wow. Thank you, Karim, for breaking down this complex term so clearly. And before we wrap up, if you have any question, feel free to reach out to our technical team. We have Brian, Karim, and Han. They're all happy to support you. And our tech spark will be holding every last Thursday of each month. So the next session will be with William and Brian. We are going to talk about the meanwhile latest NPI products, LRS 1200 series, high wattage power, green energy, and DC to DC solution. So don't forget to follow us on LinkedIn. If you have any questions, feel free to reach out to us. That's it for today. I hope everybody enjoyed today's section. Have a nice day. See you.